The purpose of this core application tool, otherwise known as CAT, is to demonstrate the use of augmented reality technology in facilitating remote maintenance of highly technical machinery. The trial involved two actors, a worker and a remote expert, and simulated a train maintenance scenario. Using augmented reality, a skilled technician, the expert, based in a remote location, can instruct and guide the worker to carry out maintenance to machinery in a depot. On screen you will see that the worker is examining a piece of machinery that requires repair. He wears goggles that provide an augmented reality view. Here you will see the expert technician in a different location. The expert is directing the worker to the cause of the problem. He inputs commands into his computer which affect what the worker sees through his goggles, directing him to the precise location of the problem. Both the expert and the worker wear a headset with a built-in microphone so they can talk to each other and provide feedback. The expert provides guidance and voice instruction by means of the headset. The main objective of Trial 1 was to check that different components, developed at a very early stage of implementation, were able to work together and to provide a real solution. This trial worked well, and the technology will be improved in further trials. The purpose of CAT2 Trial 1 is to test workload assessment using augmented reality tracking to capture the data. Here you see a worker performing an assembly task using model helicopters. He undertakes the task in two types of workspaces, one with a good layout and one with a bad layout. The data was then assessed by the human factors specialist, looking at neck bend, back bend and upper arm elevation. The indication from this trial is that the feedback is working. In the coming months, it is planned to test multiple participants with improved tracking and visualization of feedback. The purpose of the CAT3 Trial 1 is to test in a virtual environment the communication between the components and also the functionality of the hierarchical task analysis tool. A simple procedure of a spacecraft assembly is simulated. 3D models represent spacecraft parts, environment and surroundings. Two users will follow a predefined step-by-step sequence in completing the task. They will be supported by long and short instructions and other documents, all of them displayed in the VR environment. The first user is the end user. He is already aware of the CAT's functionalities and has now started on the tasks. On screen you can see the VR work environment. Next, a novice user prepares for the task. This user is dealing with the system for the first time. During Trial 1, the system was checked, testing the communication between its components and then loading and displaying them. A functionality evaluator and human factors observer provided critical feedback on this trial. The lessons learned have been recorded and the system will be improved for Trial 2. The purpose of CAT4 Trial 1 is to test the functionality of providing motor skill training with feedback after each exercise. 5 components are involved in this trial. Each one is an exercise for training motor skills. The trainee actions are recorded in order to assess whether the exercise has been performed well or badly. 5 test conditions will be used to conduct the test. ARBA and UMA will review and assess the trial, and the application will be performed by expert users from Tecnalia, not the engineers, but the ManuVAR staff. Now the trial is starting as Susanna starts to go through the test conditions for the trial. The haptic device is a sensitive instrument and takes time to get used to. Also, as part of the trial, the operator must make deliberate errors to test how the tool detects wrong behavior. The trial has successfully tested each of the 5 conditions and feedback will be used in preparation for Trial 2.